So welcome everyone in the problem solving and doubt clearing session 8 of the course ME 91 Production Technology Theory and Practice. So we start with the assignment of week 7. So this is the first question for the assignment week 7. Thermal deformation during grinding due to high temperature can be reduced by. So you know the formula for that theta is temperature. So let me write the formula for the theta. So this theta is equal to is proportional to not equal to u0 D and D and that part I'm not writing here just because here they ask just about proportionality, so those part is not important here. Okay, so just I'm writing the formula and you will get it. Okay, so this is the formula that you have, and when you have this formula you can directly check from this the increase in wheel diameter will actually increase the temperature. Okay, you know this fact. Increase the temperature, the increase in depth of cut. This is correct because you know where is your depth of cut, here is your depth of cut. Means it is in numerator. Okay, as it is in numerator means you have to decrease it. So to get this part as you have to decrease it, so this part is correct. Okay, increase in fluid velocity. Fluid velocity is in denominator. So increasing will reduce the temperature. Okay, increasing the wind rotation speed. Wind rotation speed is in numerator. So here, so this will not cause the reduction in speed. Okay, and the decreasing concentration of grain active range. This is the this part. So this is again in numerator. So if we increase it, it is problematic. So decreasing is the correct option. So what we have is 2, 3 and 5. Okay, so 2, 3 and 5 is the correct answer. Okay, I show you the formula here. From that formula you can easily get this part. Okay, so again we have a problem here. Okay, so turning operation with the sharp tool. The cutting field is given was here. We need to focus on the fact that what tool they are actually using is a sharp tool. Okay, so this 0 point is a field and the sharp tool they are given here. So as they are using sharp tool, they need to consider the proper formula. Okay, those this means the tool don't have any kind of nose radius, so it is completely sharp. So the nose radius formula you can't use. Okay, this formula you can't use with nose radius. So what the formula do you have? You know the formula that H is equal to F by tan of ys plus cot of y. Okay, the side cutting is equal, edge cutting is equal. Okay, so if you put that your feet, that is 0.2 millimeter per revolution, your tan 12 plus cot of 18. Okay, so put this value and you get answer is 0.06 millimeters. Okay, which is given here. So this will be your answer. This is how you can get the answer by the formula. Okay. So the next question, for machining of 150 long cylindrical workpiece with standard operation of 0.500 rpm and a speed of 0.5 millimeter per revolution, the overhead paid per minute was 50 rupees. The machining cost for this piece in rupees is. So you have to just know the formula. The formula is already in the slide. So you know R3 is equal to what is is I already told you this. You need to just get the frequency. The is I think the frequency mostly the is the means time required for machining one job, and that much you need to pay. So this will be this is the time machining cost. So this will be the machining cost, and you know the formula from this from your turning operations. So this is the same formula you are using here from turning operations, and after that just you need to multiply it by your labor, this labor overhead and everything, the cost that is there whatever. So this if you multiply it, because what is this is a time required for machining. Okay, as machining cost will be added to this kind either machine accurate time required to machine that object, machine that product. So that time required into overhead per time. So overhead is given per minute. So for that time, so if you multiply the time required for one machining and the time overhead given for the specific amount of time, you can get the actual machining cost. Okay, because machining cost is both. It's our overhead, everything, and our operator cost. Okay, so it could be calculated. So you have to just calculate the time required to complete that job. So you know the already the time required to complete the machining from our previous turning operations also, and it is also given in the previous slide. So it is very easy. So you know what is your L. It is simply it is 150 divided by zero point 0.5. Your speed is given and your rotation, and but okay, into 60. Why 60? Because this is 60. Okay, there per minute it is given 60, and everything is in like RPM only, so per minute only, so you need to change anything. So if you do this, you will get only 40 rupees answer. Okay, so going to next question. Tool cost per device per piece is tool cost per piece is directly proportional to time per piece. This is simple. You must know the cost values. There here they are asking the tool cost. Okay, so you could just go through the formula for the tool this tool cost. Okay, so what is the formula for tool cost? You have to check this. It is said tool cost per piece it is. Okay, so it's different than that for. Okay, you have to check first what is the value for that. So you don't have that. So to go through the 75 paper only. Here again we have tool cost per piece. We have the formula which is R5. So R5 is equal to lambda 2 by just keep it pi correct by dl into 1000 bf into bn by n the k. Okay, this is a complete formula that you have for tool cost. Okay, per piece. Tool cost per piece, it is the formula for that is directly proportional to machining time. So to check whether it is directly proportional to machining time. Okay, so same can be written as, because here the concept is different. Okay, so this is the modified formula that you should actually write, but here they are not asking, so I write both of the formulas depending upon what you require. You can choose, you can must write both of the formulas because this formula is get derived from this formula only. So here you go, directly proportional to the machining time per piece, machining time per piece. Yeah, it is here in this case it is true. Okay, you can see in this case it is coming correct. So you are using this formula now, so just write both of the formulas. So this formula you will have, you can answer from that formula. Okay, so this is here we have right proportional to tool life. Nowhere here even tool life is not there, but it is inversely proportional. See, here it is inversely proportional, here it is not there. Just we converted this just tool life into some other parameters. That is what only the question is here. So, right, so we can check even both of that, but it is not in the case. But here you can go with it. This okay here I, so TM is correct. So this part is correct, but here is inversely proportional. So this part is wrong. Directly proportional to tool cost per grinding. So here, so it is correct, and inversely proportional to tool life. This is correct because it is inversely proportional. Here we are writing directly proportional, so that is wrong. But inversely proportional is correct. Inversely proportional to machining time, so this is the machining time. So see, they are not using any term from this equation. Okay, so you need to be okay, so this equation is not useful here. Okay, but just write it so you can know if there is any problem. This is actually equation. They might ask from you anything. Okay, in exam they might ask you from anything, so you have to be ready for that. But right now from this question you can get from this itself. Okay. So from this, you know this part is correct. So you are 1, 3, and 4 with the correct answer. Okay. So for better surface finish, grinding, the grinding condition should be used to reduce the value of chip thickness, because you know the formula for that. Okay. You already know the formula for that. What is your H? H is equal to 2.225 T square max by D. So you know for better surface finish, they reduce the value of chip thickness because it is even part of in the square part. So it is a part in a square part. So speed velocity is not anywhere here. Not here. And diameter of angle is not only what you have depth of cut and thickness in which again it's primarily as you must reduce. So chip thickness. If they ask what must you increase, then it's depth of cut. So but according to the question, chip thickness will be correct answer. I show you the formula. Just I told you just write down the formula and get the answer. That's it. And if you have two formulas, just do the proper conversions in previous questions with the proper do some previous questions with this question. You need proper conversion. Okay, to complete formula you need. Okay, in this proper sort formula, but in this question don't need such kind of formula. Okay, here. So depending upon the formula they are asking you to be ready with all the formulas that we have, and your question will be very simple. Okay, as you know the formula. So this problems are mostly focused on formulas only. You know to remember the formulas that you must use. Okay, so I already told you here the achieved surface toughness 0.2 grinding width. So we know the formula right now. H is equal to 223 T square max. That's the unit thickness divided by I depth of cut. So what do we want actually here? For T max is equal to what we want. No, T max you have to calculate, and P you have calculate, H you have here. What is the H? H will be 0.2. Okay, it will be 0.2. 0.2 will be your H. Okay, 0.2, and your D is depth of cut will be 1 millimeter. So we have everything here. So just solve the formula that is T max will be equal to I just writing it directly. It's better because we have a square value here to 5. Okay, and your T max will be equal to 0.2 into 1 divided by 225, which is equal to 0.03. So your T max will be equal to 0.03. So that is the answer already there. Okay, so this is your answer. Again, in milling process, surface finish can be improved by. Okay, so for this again, you must know the answer means complete formula. So we are actually writing for milling now. Okay, so what is the formula for H here? H is equal to VF square what 4BN square Z square. Okay, this is the formula for it. So just check what are correct here. In milling process, increasing the diameter of milling cutter. So you know to improve the surface finish. I told you in the if you go through my previous assignment, I take all this kind of questions. Every kind of question is previously taken, so it will be very easy for you. Every this category has been taken. So what here we required the in milling process. What is this? It is actually a milling process. So what we required here? Low surface finish. What does it mean? Your H max should be less. Okay, surface finish must be improved. Means your roughness will be less. Means your H max will be less. Okay, this is actually your H max. Okay, told you in that assignment also. This is your H max, and you have to be reduced this. Okay, means your H max will be reduced. Hence your surface finish. What do you call as finish? Okay, just finish. This finish is good. Okay, at that time your finish will be good. When your H max is less. So how you can get this back? Check here. Increasing the diameter of the milling cutter, it will increase. Yes, it is increased because we are going to reduce it right now. H max. So as it is in denominator, if you increase that part, anyhow, your if H max will be reduced, then surface field will increase. Increasing the field velocity here. Increasing the field velocity will increase your H max will be problematic. The number of teeth of milling cutter it is here, so it is again denominator. So to increase it, okay, improved by the number of teeth in milling cutter. increasing. Okay, so this is part is correct. The rotation frequency of milling cutter. Okay, this is again correct. This part is again correct. Decreasing the frequency of milling cutter. Increasing the frequency of milling cutter. No. If you decrease this, this will increase. So this is again against. So this condition we want actually. So according to this time, these two will be wrong, and your one, third, and fourth is fourth. Yeah, this is your correct answer. Just write the formula, you know the everything, and just it is very simple. Okay, just write down the formula, and everything you will have in your hands. Okay, so for machining operation, it takes 35 seconds to complete the operation. Tool charging time is 30 seconds, and tool life is 10 minutes. If the overload and labor cost per minute paid for this operation is 30, the tool changing cost is just you need to know the formula. That's it. Okay. So what is the formula? R4 is just a standard convection. Okay. You know this formula into PCT because there the tool changing cost is involved. Okay, into lambda, and here our labor is required, not into, because in grinding the others labor is required. We are not considering that part, but in tool changing our labor means the actual labor in the machine is required, so it can come under the concept of this overhead and labor cost. So we have to check this lambda. Okay, okay. The labor and the overhead. Time actually. This is time. We are changing time, and this is frequency. Means how much time you need to change, because if our tool is getting worn out, then we need to change it. So in one machining, how much time it required to worn out the tool, that we can get by the this frequency. So okay, so this will be a machining time, and this will be tool life. So machining time divided by tool life, that will give you the number of times you need to change the tool. And okay, this is the frequency, means the frequency you will need to calculate the cost here, lambda, and the time required to change the tool. Okay, so this will need to multiply this. This is your frequency time. This is your actual time required for it. So this will consume the time required. Okay, actual time taken for this, and this will be your overhead time and workload, worker payment. So here this will be completely complete cost. Okay, as your multiplying time and your cost is per minute. So here you have time and cost is per minute, so rupees per minute. So time will cancel, and you have only rupees in your answer, as your unit answer. Okay, so what you will do here, you have to rub this part. Okay, so you know this, you don't know this part everything. So here your TM will be this machining time here. It's 35 seconds, you know. Okay, and your tool life is 10 minutes, but it is in seconds. Okay, you are this 35, so you have to divide it into 60 by 35 into 60, because it is in seconds, so it is in seconds. Okay, and here is a problem actually, because they have not taken the 35 into account, so it must be 20 by 60 again. So after doing that, what answer you will got is will be simply equal to calculate this part. So it will be, need to divide this part again. So 35 is not correct answer, I told you, because the 60 part is to divide. So according to solution it is 35, but it should not be the answer. Okay, so it will be your 35 again divided by 60. So 60 will divide will be 0.5. Okay, so the answer must be 0.5833. Okay, uh, yeah, good judging cost. See, because they haven't divided here, because it is per minute, you know this fact, that 35 is not justified by any means. Okay, this will be your answer. So go and challenge this for this answer. I told you, go and challenge for this answer. Okay, here you have to divide by 60, and this is the correct. So if they are not dividing here by 60, this is wrong concept. Okay, so you must go and challenge for the solution. Okay, so this is this seven part what you are getting actually. If we see here, the answer is actually, yeah, but it is wrong. We should be far less than this 35. Okay, go and check because it will be divided here by 60 part. It is missing in the solution. I told you already. So go and challenge for this part. Okay. So okay, in meeting operation, the field velocity used was 0.5 meter per minute. Rotation frequency of the milling cutter was 200 rpm. Number of teeth of milling cutter was 8. The feed per tooth in millimeter per tooth was. So to calculate, and again it is very simple. You just have to write the formula and it is very easy. So your F will be equal to Vf divided by NZ. Very simple formula. Just remember the formula. Vf you have feed velocity. So see it is in meter. So convert into millimeters again. What your RPM is in minutes. So you have to convert that minute. Okay, I told you in my previous assignment everything here. All other things are in millimeters. Okay, millimeter you are asking. So you have to convert this into millimeters. So you will multiply by 1000, but your RPM is in minutes. So this minute is cancelled by this minutes. So you don't need to change anything here. Okay, because in our formula we are using both that NZ we are using and PF we are using. So this V and this V will cancel each other. So this 60 or 60 will be cancelled out each other. Okay, if though you take here to take into seconds, it's anyhow will be cancelled. So let me take here and show you by doing that. Okay, so 5 to 10 raised to 3. It will be and now it will become into millimeter per second. And again your RPM is in minutes. So again to divide it means by 60. So this 60 will be cancelled. So anyhow it's of no use. And your Z, so it will be 8. So your answer will be 3.25. Okay. This millimeter per tooth. This will be your answer. 125 per millimeter per tooth. Okay. So we are going again. A mile steel workpiece is turned within 30 seconds and the tool left for that operation was 1 minute. Tool cost per grinding was rupees. Okay. As I previously told you, the grinding cost is not involved here. Means the second labor is not involved. In this case, it is not our labor that doing the grinding, it's someone else. We are setting the part to someone else. So here what we need to just calculate the frequency for that means I know how to calculate that frequency. Here we can just get R as a convention. This will be our frequency the time means, time for which we have to change the tool by using the machining time and tool life. Okay, the frequency here we can change into just the grinding because we are sending for next operator. We are not paying for that contact operator, so it will be just every cost is involved here. Machining cost and labor cost, overhead costs, the transportation cost, every cost is involved here. So what will be the answer here? TM. TM is your machining cost 30. Okay, and will be divided by 60, and the operation cost is 1. So into again for 16. So it's simply zero point 0.5 by 16 which is equal to 8. This will be your answer. So I mentioned here 8. This 8 will be your answer. Okay. Keep it green here. Okay. So just keep this part as a green. So this 8 will be your answer. Okay. This 8 will be your answer. Okay. So right now our practice set is complete. Problem from the week 7 assignment is completed. Now we go for practice set. Okay. So this is our first question now. According to the source of energy generated machining action, non-traditional machining processes are classified as. Okay. Mm, the classification of that machining process according to the source energy source usually generate that machining action. Okay. Comma here. Okay. So What is the answer for this? So you can take some time if you want. And okay, so I think you got the answer right now. So here, the mechanical energy, you have mechanical energy is correct. Thermal energy part is again correct. Electrochemical part is correct, and chemical part also correct. So all of the above must be your answer, because in your first slide itself you may go through this part, that machining parts, and which are the sources are there. So all of these are actually the sources of uh, uh, as source energy generation for non-traditional machining processes. Mechanical, we know that UCM, okay, average jet, average water jet again, thermal mean laser beam, okay, ion beam, machining, again PSC, okay, plasma cutting. So other processes are, this process of thermal electrochemical means electrochemical machining, ACM, and chemical, electrochemical machining, and AC electro and chemical, like by using agent. Okay, here you are using agent, you are using electrochemical machining and chemical machining you have to use. Okay, so all of the above will be the part here. Okay, this electrochemical, chemical, you are using chemicals only. So this all of the above will be the correct answer. Okay, all of the above will be the correct answer. So here is the next question for you. Same type of question, mostly, but slightly different, slightly changes are there. So let's take time. So my got answered in thermal energy is applied a very small portion of work surface, causing that portion to be removed by fusion or vaporization. It is considered as which source of energy? The chemical, it is not. Electrochemical, both are same, both are not. Thermal is correct. Mechanical is not a chemical. Why? Because what is happening here? You are using thermal. You have mentioned the thermal energy is applied. Okay, so the source of energy is thermal again. Thermal energy applied to a very small portion of surface, called portion to by fusion or vaporization. So thermal energy to get the fusion vaporization is called thermal part. Okay, the source of energy will be called as thermal source of energy. Okay, the thermal part is correct. Again, some similar kind of question we have. So, okay, so we will solve question here. Chemically select to remove material from portion of one part, while other portions of the surface are protected by mass. Is considered as which source of energy? It is, that's etchant. I told you the etchant part. It's chemical. So electrochemical is another concept. We are not using masks there. Thermal is not, and mechanical is not. We buy a mask. Okay. So it must be a chemical energy answer. Okay. Okay. So you can go with the standard definition. You can go to the standard definition and get the answer. So it is a chemical. Okay. So this is the next question for you. Okay, so you might get the answer by now. Okay. So ion beam machining is considered as which type of non-traditional machining process? So is it electrochemical, chemical, thermal, or mechanical? So electrochemical and chemical will not be there. The question is between thermal and mechanical. So mechanical energy is applied here or heating effect is applied. That's the question. So simply mechanical process is not correct here because we are using ions and ions are bombarded on that part. So it will generate heat here. Mechanical energy we are not using here. So thermal will be a correct answer because we are using the heat. We are pushing a very high electron beam ion so much because we are using ion beam. So ion already at high temperature, so it will be thermal. So the ions beams are using, so it will be thermal. Okay, we are not using any, so heating effect is actually applied there. So your correct answer will be thermal. Okay, so this will be the next question. You might get the answer now. Ultrasonic machining is considered as which type of non-traditional machining process? UCM. So is it electrochemical or chemical? No, both are not. We are not using UCM. Okay. Thermal is it? So we are not using any heat effect here. So thermal will again. So but we are using the forces. Okay. So we are using the mechanical energy here. Okay, so average and part and we are pushing it. Okay, we know the all the rest part. So mechanical will be the correct answer. Okay, because you are using the ultrasonic frequency to get that core send average to work is and impingement is there. So this velocity is we are using that vibration forces. So is mechanical energy is correct answer. Thermal is not, heating is not even chemical. None of this is correct answer. Only this mechanical is the correct answer. Okay. This mechanical is your correct answer. Thermal machining removes material by workpiece material. Which process thermal machining actually uses? Yes, by now you got answer. Thermal machining removes material by, is it abrasion? So no, it's not answer. Agent we are using? No, we are not using any agent. So is it thermal? No, so we are not using any agent for thermal considerations. Okay, we are not using heat any part here. Okay, so melting and vaporization. Okay, this is correct, and clogging is not correct. So this will be the correct. Clogging is like brewing process. So this mechanism is not here used. So melting and evaporation due to the heat. Okay, this fact is due to the heat. Okay, so this part only will be utilized. Okay, so this melting and vaporization will be your correct answer. Okay, this will be your correct answer. This is the seventh question for you. Chemical milling use a chemical dissolution action to remove the machining through ions in an. So which fluid you are using here? So that's the question. Which fluid you are using here to remove the material? So that's the question we are working on here. Okay, so you can take your time that you want. Okay, so I told you on the formula that which fluid you are using here. Is it electrolyte you are using here? Electrolyte is using uh, like chemical ECM. Okay, not using chemical milling, using chemical milling. Okay. So it is using electrochemical machining. Water you are using mostly in ECM or abrasive water jet. So it is not considered. Oil you are not using here. Agent is on the correct answer. Okay, because we are using the allowance to agent is actually doing that. Okay, so agent is etching the part. Okay, so this is the correct answer. All of this are two for different states, and this is not completely waste. Okay, so agent will be the correct answer. The stand-up distance provided to avoid dispersion of the fluid stream is. So this question is obviously from water jet machining. Okay, and here we are asking the proper stand-up distance that we should go with. Okay, so that is what the question is all about here. Okay, so by that time we might get the answer. Stand-up distance provided to all the dispersion of the fluid stream is 3.1 is not the correct answer. 3.2 is the correct answer, and 3.3 not 3.4 is not. So if you go properly to the slides you will correctly get the answer because the water stream will divert so like this. So this should not be happen. So this proper standard distance must be provided. Okay, for everyone need to see many things there, but according to the slides the standard point what they have provided the slides will be this answer. So you have to go by this answer. Okay, so this will be the correct answer. I told you the slides. I told you why, because this kind of thing is happening here. Okay. And we need this need to be actually like this. Okay. For that, the minimum standard distance are actually used. Okay. This is at this point minimum standard distance is actually used. As per the slides, this is where it is given. Okay. So this will be your answer. 3.2. So in water jet cutting process, the water pressure is high for. So you know the answer here correctly. So just so little bit like that only. In water jet cutting process, the water pressure is high for the thin materials, thick materials, cylindrical materials, or none of the above. The actually thin material, you can use thin material. Okay, for thin material, you should not go with high pressures. So thick material is the correct option. I know. The cylindrical material has no any meaning over here, and none of the above is not. So this is only because we are using high pressure here. You know to know the part that as we are using a high pressure here, so uh, it must be used for thick materials. Okay. High mentioned here. So this must be used for thick materials. Okay. So this is the next question for you. Water jet cutting process can't be used for which material? So what are the restriction for water jet? It is limitation for average water jet also. See, because it's the property change. It has there's a change in the property of that specific material, and due to that property, you can't use. And if if you give the proper hint that it is actually impinging on it, okay, so crack will form. So the material should not be brittle, should not shatter like a glass. Okay, so this material from here shatter like a glass itself, you know. So it will take some time to solve. But what might be the answer? We'll have just one minute. That's it. Not any big time will provided just 1 minute. That's enough for you. Okay. Okay. In this conversation itself, I told you the part that it should not be shattered like a glass. Okay. So which part should doesn't shatter like a glass? Plastic will not shatter. Okay. Composites will not shatter. Leather and copper will not shatter. But this glass will shatter. Will brittle. It will fracture. So as it will be fracture there, so this glass it will be shattered and everything will be collapsed. So the structure doesn't have anything because of the cracks. Okay. So this will be correct answer. Okay, so we can't be used for this. Okay, this is the correct answer. Okay, okay. So what is the velocity of high speed stream of water in water jet machine? The velocity at which we are pushing the water, it is again from the slides itself. So, go through it and check if you know the answer. Yeah, say it, but we'll stay here for 1 minute and after that we go forward. Okay, so I think we got the answer from the slides. It is 400 is not correct answer, not 500, not 1000. So 900 is the correct answer. Okay. From the slides, it is this much velocity is required for Trajet to cut the materials. Okay, to cut materials. That's the important part because you have to cut the material. Okay, and again, if you do this, it like it's over cost. So this is properly from start. It's correct. So again, we will have the problem here. Okay, so what the problem you are asking here? The iron workpiece has been taken for electrochemical machining. The remote rate is desired is desired is. Okay, so I think this is not important here. The gram atomic weight valence and is given that is equal to the current effort achieved. So we got I here. And what's the formula for this part? You know the formula there. Okay, Q is equal to I will show you the formula. Q is equal to AI, which is the atomic weight current, density into number of tooths, here F, which is your Coulomb's constant. This F part. Okay, so we can solve the answer now. So I told you that Q we have Q is 10 centimeter per minute, but everything here is in seconds. So convert into seconds. So 10 divided by 60. We 1 by 6 something. So 1 by 6 is equal to 0.6666. Okay. And put this part here, that is 0.1. Okay, you put this part here. This is 1.666 is equal to A. You have what is your A? 56. Okay. What is your I? I have to find out. So it will be X. I. Density 7.8. Number of tooths is valency of tooths from balance, and F is 5 is 9650. You just calculate your I. Just do proper just arrangement of the slip. I will be equal to I will be equal to like 0. Yeah, uh, 0.1666 into 7.8 to do the six into stupid slightly will be into 7.8 into 2 into 96500 divided by your 56. That's it. That's it. This will calculate by this. Just calculation left. Okay, for you. Just calculation left here. Okay, so if you calculate the answer, your I will be 4478.565. Okay, this will be your answer, which is in amperes. Okay, so it is not You will have, so this will be your answer. Okay. This I this will be your answer. 4, 5, 7, 8. 1, 6, 4, 5, 4. So here we are going for a next question. An iron workpiece. Same. No, 6, okay. So go with here. Okay. So you know the formula here. Okay. What is the formula Q? You know it is actually again in meter minute. So you know to convert as by 50 by 60. So it will become 0.25, and which is again equal to AI into PZ, which is your density in Z is your balance, and F is your Coulomb number. So calculate. So again, this calculating here, 0.25 into is equal to 56 into I. Then the same problem will be have, that is yours 2, that is your variance actually to 7.8 into 96500. So just same it will have right now, exact same. Okay, so what we'll do here now, your I will be here only. 0.25 into 2 into 7.8 into 96500 divided by 56 will be your answer, which is again I'll show you that slide, that I will be equal to 6720.5357. Okay, you mentioned here, okay, this will be your answer from the calculation I showed to you. Okay, in this calculation you will have these answers. Okay, so we will move forward here. So typical diameter of average particle in average jet machining is, we are right now moving for average jet. Okay, so your answer will be specifically for average jet now. So it is, if you go to the slides, you get answer. Slides. This is okay. So if you just wait for a minute. Okay. So the typical diameter of average particle in average jet machining is, okay, this is, yeah, this is not correct. So this is also not correct. Actually very high. Those are actually high. Okay, so this must be like this small only. So these two are actually high, and this is not that much high. So this will be a correct answer. Okay, because this is I told you this is high. So only this it will be a correct answer because it is slow, small. So we need the small part only. So as it is a small part only, so it will be have a more better surface finish or more control over the machine. So we will go with the smaller average particles in average unit. Okay, this is correct answer. I told you. So the 14th question for you. The material removed in average unit machine takes place due to. So we are right now working with the mechanism that might required for that process. Okay, so material removed in average jet machining takes place due to which process? That is what actually we are asking here. So does it by laser? So in case of average water jet, average jet laser has no meaning at all. So HLT is having no meaning at all. Impinged electronics again have no meaning at all. It impinging only because we are using the jet of abrasive. So impingement of fine abrasive particles might correct, and it is actually the correct answer. Okay. So this is your correct answer. Okay. So if you go, this is impingement is your correct answer. Okay. So 15th question: measured contouring parameters in abrasive jet machining process are. So to go to the slides and check the value of the parameters that actually affect your average jet machining process. Okay, okay. So if you go to everything, so the abrasive matters. There's a major control parameters. Just abrasive matters there. So yes, abrasive will matter. Okay. So yes, the abrasive will matter, and the gas. And the gas will so because we are when you are going to gas again matters because you are showing it through gas only, and the nozzle again will matter. So the amount it will spread, the amount of it will the initial diameter it will have. So those things will is important here. Okay, and the abrasives again, which is actually the abrasive machine, so abrasive is important. We are using air jet. Yeah, so gas is important, and nozzle is again important to fix the diameter that it should have. Okay, so this part so is important. So all of the will be correct answer. Okay, here. So this all of the will be correct because all of this will actually matter in this process. So this will be a correct answer. Okay, all of the will be a correct answer. 16th question: abrasive jet machining. When the mass flow rate of the abrasive increases, the material removal rate. So we are actually going from slightly higher part, and it is actually there in your assignment. So it will be very beneficial for your assignments to if you already go through such kind of problems previously. Okay, okay. So in appreciated machine, we are in. So in abbreviated machining, when mass flow rate of abrasive increases, the material removal rate will mass flow is increasing. Your material removal rate will always it will increase. Okay, so this increase is your correct answer because you are actually increasing the abrasive. Your flow rate means more number of abrasive will be there for more abrasive for cutting. So your MRR will increase. Okay, so because number of cutting is increase and your MRR increase. Okay, so this is connected to this which is increase. Okay, so this is the correct answer. Increase. So increase is the correct answer. Okay. In a WJ, which material of nozzle has highest life? So the nozzle material we are focusing on. You can take your time, think about it, go to the slides, and you can answer this problem. Okay, it again, simple. Does it tungsten carbide sulfurate size ratio? Tungsten carbide, if you go through, it doesn't have highest life. Okay, you might know this fact. It doesn't have the highest life. Seraphine is undoubtable actually. I don't know about this. So the Seraphine will be correct answer because it has like 300 hours of time. Okay, 300 hours. Okay, so 300 hours is the correct part. So the Sapphire, the 300 hours is again the correct part. Okay, so Sapphire is the correct answer. Okay, so the next part for you. Okay, so in AWJ, average jet positioning, if continue to increase the standoff distance, what is it will generate in velocity of average particles at MRR. So what will case happen in MRR? So MRR will, because we are continue to increase. So beyond limit you are actually increasing. So what will happen in case of velocity of average will decrease because of the uh, standard distance is high, so it will decrease and your MRR will again because of the velocity again your MRR is decreasing. You know the velocity is decreasing, your velocity part is decreasing here, is decreasing and your MRR is also decreasing because both are interconnected. You know velocity is equal to MRR. So as your velocity will decrease, MRR will also decrease. So decrease will be the correct answer in this case because we are continue to increase your standard distance. In those cases, your velocity will go down. At a specific level, it will go down, and after it will go down, your MRR will go down. Because as you are continue to increase, so it will go down definitely. Because at some point, this graph will like go and go down, like this part you graph we have, and here this is here that you will increase and again increase. Okay, so you must know this part. Okay, so this will be the correct answer. Increase, increase. This decrease, decrease will be your correct answer. Okay. So this is 17th question for you. In West, after critical field force, the material removes weight. What happened to the material removes weight after the critical field force? Is it decreasing, increasing? I told you after critical it must decrease. So is it remain unchanged or not? Okay, I hope you get the answer. It will decrease. Okay. After field, it will decrease. After critical field point, because of the many parameters, what crushing will happen. The many factors will accumulate there, so to which most of them will crushing will happen. Critical field force, okay? So it will crushing phenomena will happen of abrasives. So due to which what will happen? Water removal will decrease. This decrease will be your answer over here. Okay. Now we have what you see. Which of the following are important process parameters? Okay, so you know the answer for this, the frequency. Yes, does matter. Amplitude, yes, it does matter. Static load matter. Grain size matter. So every of these will matter. So your answer will be all of the above, as everything is matter here. So the frequency of amplitude, static loading, okay, grain size, so everything will matter. So you can go to the slides. It is clearly mentioned there. So all of the above will be correct answer. Okay. Yes. Okay, you see again the viscosity of the fluid increases. The MRR with the change in the viscosity, your viscosity is increasing here. What is problem with your MRR? As viscosity increases, your MRR will. That's the question over here. What will happen to your MRR? Oh, it will decrease because the force will increase. As viscosity increases, the means tense fact will increase. There is restriction in the motion of abrasions obviously, so it will decrease. Okay, so this is the correct answer. So in you are saying the surface finish is more sensitive in case of for it is if you go through the slides it is there. So surface finish is more sensitive in which case? If you go through the slides properly, it is there mentioned there. So go through slides. It is simply there. Okay, if you go through the slides, so it's simply SIC has no matter. So yeah, it's a glass. It's also not matter because surface finish is sensitive in case of glass. Okay, glass because it is brittle. So glass is brittle and it's problematic. So the surface finish is sensitive in case of glass part. The SICs are all abrasive, so they're nothing good because all of these parts are actually abrasive. Okay, so these things doesn't matter here, but this is which it can matter well. Okay, so you must remember this fact. This is actually slight, it's like corner point here. You get extra marks. In museum, what is the use of concentrator? You know, we are using concentrator in museum. So what's the use of the concentrator in museum? That's the question over here. So go to slides or you know the answer. Just after waiting, we solve the answer here. Okay, just wait for a minute. If anybody want to solve that, you can solve and be ready with the answer. Okay, if you go to the slide, so to produce a vibration tool, you have different arrangements. So concentrated is not going to generate vibrations. Supply high frequency current is again different concept to hold the head. Again different concept to mechanically amplify the vibration for transmitting it again. Yeah, it is actually the correct answer. Concept is used to. So this is the actual reason for which we are using that. concentrated. Okay, so you see me everything for these reasons. Okay, to increase the file transmission, amplify as an amplifier you're using for concentrated. Okay. So again, in ECM, diamond dust is only used for abrasive slurry for cutting. Which material is rare? Like diamond, rubies, both A and B are above. Diamond, so diamond obviously will go with, but is it case of rubies also we are using it? That's the question. So if it is a cancer, a C will be correct answer. You know, D is anyhow will not be correct answer. The question is between is A or C. You must know this part because difference between A and C. Okay. So if you got the answer, it is both. Because it will be case of B. So as with this A and B, so both A and B will be correct answer. Okay. So both A and B is the correct answer because you use it in both of the cases. Okay. Okay. In ECM, workpiece is connected to electrode and the two to electrode. Which electrode you are connecting it? So it's again you can take more time if you want for because it is complete. This is the question. Why? So it is also the assignment, but it is necessary question. So take your time. So obviously this negative will not be the correct answer. Negative because it current will not follow in these cases. So this workpiece is connected to it because electrons will be emitted from one point and deposited to mostly go to different points. So we'll see the answer. So negate is positive to the workpiece and negative to the electrode. So actually material is moving from positive to negative, you know, and the current is going from negative to positive, and the material will go from positive to negative. So to get more, to get more material, more you connected here. Okay, workpiece is connected to positive terminal. Okay, and electrode tool to negative. Okay, so this will be a correct answer. Okay, so it ECM, the dilution rate is maximum where the gap is specific questions are actually. Okay. So the distribution rate is maximum where the gap is less, more independent of it or none of the above. So it is less because we have maximum dissolution rate. So when the dissolution rate will be maximum when the gap is less. because it would facilitate more, what we say, chemical ingredients. So this will be the correct answer. Okay. This list is your correct answer. Okay. This it must be gap must be less to get more ECM and restoration rate and to get more MRI. So again we are going for ECM only. So typical range, typical material removal rate is, so we have to go through slides. So this is some small part to focus on what might be typical rate of it, so we get idea about what typical rate it might follow. Okay, that's why I added this question here. So to get small corners where you can probably miss. Okay, and this type of questions are there maybe be asked because mostly the problems are applied. You can see from the assignments the problems are mostly applied on the applied side. So you need to be focused on this part. Okay, so mostly problems are on applied. Okay, so what is the typical value for this? Yeah, 61600. Okay, so it's typical value in meter per second. So this will be the correct answer. Okay? 600 is your typical value of material movement. Okay, in HCM for 1000 ampere of current. Okay, so we are asking here for variation, the way it varies. Okay, in HCM, the with increasing hardness of workpiece, what changes does it make in material removal? So in ACM, with increasing hardness of the workpiece, the material removal rate will, what will happen to material removal rate? Whether it will increase, decrease, or is independent of it, none of the, what it will be, either it will increase or decrease. So to go properly to the slides is not increasing, not decreasing, and not none of the above. So it is independent of it is a correct answer. This is the correct answer. Is independent of it. Okay. C is independent of it. So this is why we form the question that you might get the answer is like increasing or decreasing, but actual answer is independent of it. So this kind of smart problems might be asked you in a question. So in assignments, not in assignments. Assignments also there are there. You can go through there are there actually. And in the final exams also this kind of smart question will be asked to you. So you'll be ready to get such kind of smart answers. And both you must know the complete area and you must go to the proper slide. So you will get such kind of answers properly. Okay. So we will go to the next question. Again, in ACM, which is a true in case of toolware. Again, smart question we are asking. So we go through slides properly and answer it properly. Okay, it is a smart question. If you know, then you know what the answer here because it is a smart question. The question itself is a smart. So the answer, the student who will answer must be more smarter than the question to get the marks for it. Just you are asking which is true in the case of toolware. That's it. It's very critically formed. So this kind of problems you might ask in exams. So be critical. Be working on this one. So as I earlier told you, it's a smart question. So it increases with the time. Toolware increase with the time is not which is not a guarantee. Decreases with the time is the inverse. It is not true. Acting no toolware is the correct answer. I told you it's a smart question. Not the way wrong. So it is independent of that part. So it is practically there is a no toolware. So see how the question is formed, what the answer you get. So you need to be smart while solving such kind of questions. Okay. In lithium, the amount of any material dissolved or deposited in proportional to is proportional to what quantity? It is straightforward. It's not that much hard question. So it is very straightforward question. So you can solve it very easily. You just go through slides. That's it. You have to understand the concept. If you understand the concept very well, then there is no any problem or to get such kind of difficulty in solving this kind of questions. Okay. Okay. So we'll wait for a minute and after that we will solve the answer. Solve this question. Okay. The solution is I will tell you the correct option for this problem. Okay. You said depending on the electrolyte of the flow rate, electrolyte pressure, electrolyte type of electrolyte, electrolyte flow rate, it doesn't matter. Okay. That is all deposited. You might think that, but it is not correct answer. So type of electrolyte is no, it is still not the correct answer. If you go to the site, you might know the answer. The quality is fast is the correct answer. Okay. To the electrolyte flow rate and the deposition result proportional to not electric, it doesn't matter. Because the proportionality doesn't have anything for that. Electrolyte pressure, it is not there actually. So type of electrolyte in electrochemical machine does matter, but the quantity of electricity passed actually causes the ions and the proportional to this part only. If you know the formula, you can get this answer. So pressure and the flow rate and those are nothing that considered in this case. So in this part of the case we consider. So this is the correct answer. Yes, yes. And we go with the alternate question. So recast layer of microfiles are inherent feature of which process now? So we are changing our process now. Where the recast layer and microcaps are for inherent features of what? Very costly, It will take more time for this. This is not it's very simple. This from advantages or special disadvantages of work machine. Okay, so we'll go through the slides properly. We get this answer very well. Okay, recast layer where recast layers are formed and microcrystals are generated. In ECM, there is the formation of recast. No, in any of the three of the processes are completely different here. So only one EDM will be the answer for. Okay, so all of the other processes are completely different. This UCM, AWG, there is no information of recast, no any information of recast here. Okay, so okay, reclass are not formed. Microclass might be present, but this recast will not form. So idiom will only your correct answer. Okay, so this is idiom correct answer. Okay, so LBM is generally preferred for which stocks? You can go through the advantages of each. The LBM specifically, and you can tell the answer directly. Okay, it will take time as per you want. So what for what you can use LBM? For thick stocks, laser can't penetrate up to thin stock. The cylindrical stock has no meaning here. None of them was no meaning. So what soluble left with thin stock only. Thick stock is not used. Cylindrical has no meaning and thin stock only because it is just on surface layer part. So it will not penetrate that much. Laser is mostly used for thin part. Okay. Mostly lasers are used on thin parts only. So it doesn't penetrate that much. So it is not can't be used for that much penetrations. Okay, so thin stock is only preferable for laser beam machines. Okay, so thin stock will be your correct answer. Okay, so we're going again forward. Which process uses plasma stream operating at a very high temperature to cut the metal by melting? Cut actually. We are using plasma. So, okay, plasma stream we are using. Directly answer is shown to you because where you can use plasma and same PSC, let's say, but you need to know the name. What is PSC? What is LSB? What is HSB? That is again a smart question you have to unique here. So UCW, LBW, and the PSC. You need to know the answer of this. If your answer is very straight from the question, you can get the answer. It is very straight, but you must know this part. This what missing, called what LB, called what pack, called what WCC called. If you know this part, it's very simple. You can within seconds you can answer it. Okay, so go through everything properly and check what is the correct answer for this problem. Okay, So you know what machine is called as ultrasonic machining, LPM and laser beam, and PSC is actually plasma cutting. So the process using a plasma cutting only from the name itself, it is very easy to get to that part. Okay, so AWE is not using that, and LSB is complete different concept. So all from the name itself you can get the PSC will be different. It is called as plasma. It is called as plasma. Okay, so it is a P and it's a actually cost here. Okay, so this is the correct answer. Okay. Okay, so what is the range of temperature which is used in plasma? So we asked previous question we see it is very high temperature. So what might be the amount of the temperature that is actually involved in those cases? So that is what we are asking here for you. So just state for the amount of temperature range which is actually present for tank this plasma. Okay. So what is that range we are using? Okay. Yeah, I hope you got the answer. Okay. So what is the range that we are using here? Is it 1000 to 2000? It is very small. It is not called as plasma actually. So this cannot be the answer. And these all are very high and low. So this is only the range. So you know this part. This is the range when we actually go for plasma arc cutting process. So this is the range mentioned in the slide. So in the standard mostly. So you can go through the slides to get such kind of answers. Okay. So okay, we are going for EVM now. EVM is mostly used to drill the holes with small depth to diameter hole ratio is very high. So what up to what level you can go to? So that is the question here. Okay, so up to what level you can go through? That is a question. So we have to go through the slides properly. Even the previous question, the range at which it is coming. So from slides you can get those answers very easily. Okay, so just go to the slides properly and lecture series properly so you will get the answers effectively. Okay, effectively means easily, more easily you will get the answers for those questions. Okay, so this is the question for you right now. So just go to the slides, you can get the answer. Okay, so okay, so 100 and it is not correct answer because it is actually more than this. So as I told you, more than this, so this already collapsed. So only this part is actually more than this part. Okay, this is actually more than this, so this will be a complicated answer because it is not used for used for smaller than this part. So it is only for more than this part, more depth than diameter. This is for small holes we are using this process electron beam machining, and up to this level you are using because it must be satisfy the cost required for that machining process. So it is actually more than this part, so this must be less for test part. So only this part is more. So this is going to be correct. Rest all of that wrong. Okay. So So this is the correct answer only. So right after that we'll go for question. And I already told you the answer. Okay. So this question is the same question. I already told you how to solve it. Again, just follow the give the formula for you. But here we are actually need to calculate the same quantity. Actually, just calculate the given rate. So you have to find out the Q over here, and it is electrochemical machine. You know this part is electrochemical machine problem, and we are going to calculate MRR. So MRR, what is MRR in this case? If your MRR will be equal to your Q, which is Q, which is equal to your AI, which is your current and atomic weight into density into number of valence into your this coulombs constant. So just stop. So you put the values everywhere and solve the answer. That's it. There is no nothing much in this question. Okay, just put your answer, values and solve the answer. That's it. Take a time that what. But here we are using iron. So and just calculate the Q. In the previous questions, we are calculating the I and other things. Simple, just here is very simple. Just calculate the Q. Just put and you can solve it by yourself. Because it is not. We are already solved it, so you can take a time like 2 minutes, 3 minutes. You can take to solve the problem. It is not even for that time, but you can take. Okay. So simply you can put the point here like you have A here, amperes. You have this I, that is A, this 2 and this 7.8, and this one you have put this to put these things here and you can get the answer. Just part of calculation, that's it. It's not maybe it's okay. You can go to calculators and just put everything in value. You get the answer. Okay, so what you will put? You have this your this part that is atomic orbit, which is 56. 56 into 1000, 2000 ampere, and your density is 7.8 and into 2 into coulombs, that is 96500. Okay, so this you will put and your answer will get. Yes, got. Just put it here, you get this answer. But what we want? We want in minute. This is in seconds. So what we want is actually in minutes. Okay, what we want here might be get confused. What we want here in minute. So to multiply here 60. So if you multiply here, what answer you will get is. Okay. So answer you will get is I told you there also 4.4639, okay, centimeter cube per minute. So this is your answer. Okay, so 4. So this is actually told you 4.4639 will be your answer. Okay, just put the values and its answer will be very simple for you. Okay, this is the same question again. Try by yourself. First we are using titanium material, and then iron we are using titanium as a material, and the properties are changed for titanium now. Let's see what material will we make it by using this concept. Okay, it is increased or decreased. Obviously, we get it is decreased directly, so we are changing almost properties here also. So you can actually tell you that because it is not comparison anyhow, we are changing the properties. meaning point of exercise changing current also. So it will not be part of it. So just calculate the values. I already told you the formula. So take a minute, like 2 minutes you will have. Solve it and check the answer afterwards. Or you can fast forward it even. Okay, so solve your answer. You can have a 2 minutes after that will solve for you. So just wait. So we have a light problem here. So this is the these properties are given to and calculate the material removed. Just calculate. We have time. Just take 1 minute or more. And it is exactly same. That the way we solved here, the formula is exactly same. The question is exactly same. That we're changing the values. So you must get the answer. Okay, just like exactly same formula we have. So everything is exactly same. Just what you need to do, you need to just put it in proper formula. That's it. This functionality is gone. I need to change this things. Okay. So I have to see this solutions also now. Seeing this is a problem. Yes. Okay. So, okay, so what is the solution here? Just solve it now. You have q. What is q is equal to? What is this q will be equal to? AI by e z into f. So I already tell you everything. Like 48 into your current 2700 into your density, which is equal to 4.5, into your balance, into your this Coulomb's constant. So this will again come in because again you are asking here in minute. So this will again come in second. Just multiply it by 60. You will get answer it. And it's 0.0999481. So again you have to multiply it by 60 into 60. Okay, we multiply this part to get into Q will be in centimeter cube into uh, minute. For that, multiply the 0.099481 into your 60. So your answer will be 5.968, okay, centimeter cube per minute. So this is your answer, 5.968 centimeter cube per minute. Okay, so we are right now going for other problem. The okay, so this is another problem. AUCM. The volume of work material removed is directly proportional to. So again, it is formula based. It's completely formula based. So depending upon what factor you are asking here. So first thing depends upon which factor. Or that is a question that you are asking here. Okay. So take time or go through slides because it is in their slides also. So you can go to slides to get a proper answer here. Okay. So it is in the slide. So simply will take a 1 minute. You can have a minute to go through part time. answer the correct option here. Okay. Okay, so I think we go through the point. The volume of point pointer mole per impact. Yeah, it's correct. Number of particles emitting impact cycle. Yes, it's correct. Frequency. Okay, so all of the part are correct. For MRR, is proportional to all of them. So if you go through the slides, you might get this answer. So all of them are correct. So is your correct answer here. Okay, so again we are going for problems now. So if you are working for EDM, you know the formula for EDM. What is the formula for MRR in EDM? So in EDM process, the current of voltage supplied is given to you. T on T of is given to you to calculate MRR. So you must know the formula for MRR here. So your MRR is equal to G into V I, and you have 1 plus T off by T on. So so what just go through the part that you have over here, and what asking, just they are asking MRR to you, and even the it is in milligram per minute. So the constants are given to you in that way itself. So you see, but it is in seconds. So everything must be in seconds. That is part. And as it is in seconds, you have to multiply it by 60 to get into minutes, because answer we want answer in minutes, and answer is in seconds. So one need to convert it into minute part. That's just this you have G you have here, the V you have, I you have, T you off you have, T on you have. Just put the values here and get the answer. That's it. That's simple it is. So just solve it by yourself. Okay, just solve it by yourself. Just put these values that G you have and everything you have. So 1.666 into 10 raised to minus 5 into your voltage will be 100 into 5. This is divided by 1 plus T on, which is T on is 2. Yeah, so 10 by 2, so it will be 5. So it will be 6, and 100 by 6. And if I just divided this part, so uh, yeah. So what answer you will get will be 1.38833 into 10 raised to minus 3 milligram per second. So multiply it just by what value multiply? This multiply by 60. So you will get this answer 0.88333. So multiply it by 60, that answer. So you will get 0.08333 milligram per second. Just converting the 12 minute to second part, just multiplying by 60. So this will be your answer. This is the same problem you will have here. So solve by your own. You will have 4 minutes, even 4 to 5 minutes if you required. But solve it by your own after you solve the question. Here what we want MRR again. So it's exactly same again again you see the unit it is, which unit you are having, meter per is mg milligram per minute only. So exactly same, and constant is also same. values are changed, so we change with that value and solve that problem. That's it. That's it. That's it. That's it. You have the formula already, so just to solve. Okay, you have the formula already with you. And just write the formula in case you want. P into P into I divided by. Okay, so I need to go somewhat closer. 1 plus T of by T on. Okay, here on. So make it bracket here and we'll solve the question. You can solve it by one. Okay, it is very similar. You can solve it by one. Okay, so you have G which is given here. You have V which is again given. I current is given to, voltage is given to, T on is given to, T off is given to. So just put it in the formula and solve the answer. Okay, so your G is here 1.666 to 10 raised to minus 5 into your voltage is 120 into current 8 divided by 1 plus your T off is 6, so 6 by 1.5. Just solve this and again for this answer to multiply by 60 to get answer in milligram per minute. Okay, because our constant is in seconds, so and the required answer is minutes, so you need to change the minute part to get correct answer. Okay, so solve it by your own. So everything is on the table. Just use your calci and tell the answer. That's it. Okay, that is what we're doing. Just tell your answer. You put correct everything here, so your answer will be in this case. So your answer will be 3.19872 into 10 raised to minus 3 milligram per second. It is okay, giving milligram per second, and but your answer must be in minutes. So just multiply it by 60. So after multiplying by 60, you will get this answer, right? 0.191. So this answer will get after multiplying by 60. So this again will be milligram in minute per minute. Okay. So this will be your answer. 119 is your answer, which is shown here. So we have a few more questions. That is two questions. So again we have the same process EDM, and the current and voltage supplied is 5 ampere, and our current if T off is given to you, but T on is not given to you, and MRR is given to you. So you need to use the same formula, calculate the T on. But it is slightly complicated because is slightly mathematically expensive because right now it is divide 1 plus and divide factor, so you have to be slightly accurate with your answers. Okay, so you know the formula again, which is the MRR. So I just keep it slightly small because it's slightly long problem. Your MRR is equal to G into Vi divided by 1 plus P of Y P on. Okay, P on is again problematic, so it is just like just small problem. Okay, so here, so right now we go with okay, so let me solve it for you. Okay, so this 1.666 is a constant. 10 raised to minus 5 into your V is 5 and it will be 110, and your 1 plus T of is given to you. You have to find this T on. Okay. And what is your MRR here? It is in milligram per minute. So but your constant is in seconds. So what you should do? You should divide it by 60. So it will be already small, like 1333 to 10 raised to minus 3. So how so what is your problem completely formulated now? So this is all the prerequisites for a problem. You know the formula, and right now what we wrote is 1.33. Right here 1.3333 to 10 raised to minus 3 will be equal to 1.666 into 10 raised to minus 5 into 5 into 110 divided by 1 plus 7.5 into T of. So we have to solve this problem strategically. Okay, so what we can do, just keep everything on that side, so it will answer. You can keep all this things to that side, so this part will come here and this will go out. This will come here. So what we'll have here, just make it just solve it here. Okay, so it will be 1 plus 7.5 by x is equal to, we just multiply, do that calculations there, up to 9.163 into 10 raised to minus 3 divided by 1.3. Just what we did in this step, just this part, means this part we just calculated. Okay, so this part we calculated here, this part will come here, and everything is just same. This part we just came here and everything is exactly the same. And what will now we will do here, we will calculate this answer. This answer you can just divide it. It is 3 1 cross, so somewhat 6 is the answer actually. So 7.5 by x, which is equal to 6.8739 minus 1, because this 1 will go there, and your 7.5 by x is equal to 5.8739, and your x will be, you can just do this, keep here and keep it here. It will be 1.27 microseconds, because this is in microseconds. Okay, this part is in microseconds, so this is again coming microseconds. So 1.27 will be your answer in this case. So this is how we can calculate your T1, and so this is your answer. It is mentioned here because we wanted microseconds, so it is in microseconds. And this is your answer. So this is your last question here. So solve it by yourself. You will have 2 minutes. I will must solve, and after that we can wind up this session. And here what we need to find out, the voltage which is supplied here. Okay. I told you the formula is exactly same. So your MRR will be equal to G into VI by 1 plus P of by T on. So it will be equal to 1.666 into 10 raised to minus 5 into your V is you have to calculate. So it will be like V, I you have the 12 ampere, and your 1 plus you have T on is 3 and T off is 8 by 80. So we have calculate first is 8 by T, and your MRR is again different here. So MRR you have, and value of your MRR again is in minute actually, so convert into seconds. So it is 0.5 by 60 is equal to 8.333 recurring from 10 raised to minus 3. So your problem will become, will have a different color code for this brown. So your problem will be 8.333 into 10 raised to minus 3 is equal to 1.666 10 raised to minus 5 into b into 12, and you guys call this answer. This is simply 8 by 3. Okay, so we just calculate here. So it will be 8 by 3, 8 by 3 plus 1. So this is 11 by 3, and okay, so it is actually 11 by 3 is 3.666, but we keep it as 11 by 3 and convert opposite to multiply the entire part, because anyhow we just want b, or you can just get this part like 3.6 calculated here, 3.666, and so your v will be, just keep everything here and kept v on one side only. So we kept our v on one side, and you are right now progressing with the solution. So it will be 8.3333 raised to minus 3 into 3.6666 divided by this v is there, so 1.666 into 10 raised to minus 5 into 12. Okay, so everything you have here. So the answer will be for voltage 11.35 volt. Okay, so answer that we calculated is 11.35. So after the calculation you get this answer, that is 11.35. It is 11.35. Okay, so your answer is, after every calculation everything you put there, your answer is 11.35 volt, because we want to calculate the supplied voltage. So your V is 11.35 volt. Okay, so this is our last slide, and we concluded our problem set for this week 8. Okay, and we will keep this part. Okay, so again your submission date for this assignment will be Wednesday, and so do submit it and challenge the questions that you see which is wrongly solved. And this session 8 is, we are ending here. Okay, thank you for joining, and this is the end for this problem solving session.